After a little testing and using it for a couple of battery packs, I have encountered 3 problems. I believe 2 of the problems are going to be easy to deal with. Unfortunately, I think the third is going to require some redesign. The first problem, the cheapest to deal with, has to do with the acetal nut in the right pressure block. The right side is noticeably noisier and having problems settling on the pressure. The nut to threaded shaft fit is just too loose, and it really creates problems for the servo control. It's hard to tell from the video, but there really is a lot of play in the threads. I'll make a new nut, and that should take care of this problem. The second problem, the 110 copper I use to make the tips. It really sticks bad to the nickel battery tabs. The easy part to fix this problem is just ordering a set of Glidcop tips made just for battery tab welding. The downside to that, $35 is a bit expensive for the set of tips, but I could not find anyone selling small quantities of the Glidcop alloy, and from my research it seems to be the preferred material for the electrodes. The other option seems to be an RWMA Class II copper alloy, like copper 182. $35 will buy quite a bit of copper 182, so next time I need to order metals, I'll get a short piece of it. Then I can make some tips to compare to the commercial Glidcop ones. The last problem will probably not get dealt with for a bit. It's more related to performance and reliability, but it will have to be fixed. This problem has to do with the way I'm transferring the pressure on the threaded shaft to the load cell. Right now the shaft is just clamped to a small deep groove ball bearing. Probably the maximum axle load on a bearing that small is just a few pounds, and I know I'm exceeding that. So I knew I was going to have to replace the ball bearing at some point. But what I was not expecting was uneven arm movement on the load cell as the shaft turns. Early on when I was testing the load cell, I thought I was having a hysteresis problem. I didn't even think about the bearing wobbling one side of the load cell up and the other side down for half a turn of the shaft. So I have to figure out a way to uncouple the wobble in the shaft from the load cell. And I don't think just replacing the ball bearing with a thrust bearing will work, because it looks like more than just radial wobble causing the problem. But while I'm thinking about what to do about the wobble, I'll make a new pressure block nut and get the right tips, and it will be good enough to use for a bit.